Fine. Let's start. There is a volcano on Io, one of Jupiter's moons, that is 202 kilometers wide. That's roughly the distance from New York City to Philadelphia, but instead of suburbs and highway, it's a lake of molten lava. It's called Loki Patera, and we've been watching it for 45 years. Here's the thing, we still can't predict what it's going to do next. Loki goes through periodic eruptions where the solid crust on top of the lava sinks back into the molten rock below, like a conveyor belt of fire. For a while, it did this every 540 days, almost clockwork. Then, in the early 2000s, it just stopped. No eruption, nothing. Then it started again, around 2013 on a different schedule, 475 days. A researcher named Julie Rathbun spent years tracking it, predicted a May 2018 eruption correctly, then predicted September 2019. It came early July. The volcano shrugged. She said, and I'm quoting directly, "We need to stop naming features after trickster gods." But here's the thing that actually gets me. When Juno flew past Io in December 2023, it imaged Loki up close. And inside the lake, sitting in the middle of all that churning, sinking, overturning lava, there are islands. Rocky outcrops just sitting there, unmoved. And when scientists checked the Voyager, one images from 1979, the islands were in the exact same spots. 45 years of constant lava activity, and nothing moved them. No model explains this. The solar system named something after a trickster god, and the trickster god said, "Watch this." Number 9. Io, again, but a different problem. A worse one. Io is the most volcanically active world we've ever found. It has hundreds of volcanoes, massive ones. The kind that would make anything on Earth look like a science fair project. And we understand broadly why. Jupiter's gravity is so immense that it physically squeezes Io as it orbits, generating enormous heat through friction. The same way a stress ball warms up if you squeeze it fast enough. Fine. We've known that since 1979. What we didn't know, and only confirmed recently, was that the volcanoes are in the wrong place. When scientists mapped Io's eruptions, they found that the volcano locations are systematically offset from where the tidal heating models predict they should be, 30 to 60 degrees off. The biggest, most powerful eruptions cluster almost entirely on Io's trailing hemisphere, the side facing away from its direction of orbit. And as Catherine DeClear at Caltech put it, no one can really explain this volcanic bias right now. But here's the thing. In 2023 and 2024, the Juno spacecraft flew within 1,500 kilometers of Io's surface, close enough to measure its gravity field in detail. The mission was specifically designed to test whether Io had a global magma ocean beneath its crust. Every model said it should. Tidal heating at that intensity, sustained for billions of years, should have melted the interior into a continuous layer of liquid rock. It wasn't there. No magma ocean. Or at least nothing we can detect as one. Just pockets, maybe. A sponge of partial melt rather than a clean liquid layer. This matters more than it sounds. Because the same tidal heating models we use to understand Io are the ones we use to predict liquid water oceans on Europa, on Ganymede, on Callisto. The Europa Clipper mission, launched in October 2024, $5 billion, is headed to Jupiter's moon Europa right now, banking on those models being correct. And we just discovered the foundation those models were built on may not exist. Number 8. Mars is supposedly dead, that's the official position. A cold, dry, geologically inert rock with a thin atmosphere and no meaningful chemistry happening at the surface. That's what we thought. Then Curiosity drove into Gale Crater in 2012 and started sniffing the air. The first surprise was methane. Methane shouldn't exist in Mars's atmosphere. Ultraviolet radiation destroys it quickly, so if you're detecting it, something is actively producing it. And Curiosity kept detecting it. Spikes. Random, erratic, appearing overnight and vanishing by morning. In June 2019, it recorded the largest spike ever. 21 parts per billion, 3 times the previous record. No one has explained where it's coming from. Not satisfactorily. The leading candidate in 2024 was that salty soil crusts are trapping and releasing it, but that doesn't explain the origin of the methane itself. It just relocates the mystery. And then, in 2019, researchers published a second finding: oxygen. The oxygen in Mars's atmosphere was doing something it shouldn't. Every spring and summer, oxygen levels in Gale Crater climbed up to 30% above what models predicted. Then in winter, they dropped below expected levels, a swing 6 times larger than any known abiotic process could produce. Here's the thing: the methane spikes and the oxygen spikes partially correlate. They don't match perfectly, but they track. They rise and fall in a loose rhythm with each other and with the seasons. On Earth, the most efficient known mechanism for producing both gases simultaneously in fluctuating quantities tied to a seasonal cycle is biological metabolism. Nobody is claiming life on Mars. The scientists involved are being careful and measured and appropriately skeptical, but nobody has an abiotic explanation that actually fits the data either. Something is cycling gases on a dead planet. We don't know what. Number 7. In January 1986, the Voyager 2 spacecraft flew past Uranus, and on the way, it passed a small moon called Miranda. Miranda is tiny, only 470 kilometers across, smaller than the distance from London to Edinburgh. At that size, you expect a moon to be a boring, cratered ball of rock, geologically quiet, featureless, dead. Miranda looks like it was built by a committee that hated each other. Its surface is a patchwork of completely incompatible terrains. Ancient, heavily cratered regions sit right next to young, smooth, grooved areas called coronae that have almost no craters at all, meaning they formed recently, geologically speaking. These two types of terrain shouldn't be on the same world. They don't belong together. The first explanation scientists reached for was that Miranda had been blown apart by a massive collision and then reassembled in a scrambled order, like shuffling a deck of cards. Then, they ruled that out. And haven't settled on anything else since. Miranda also has Verona Rupes, a cliff approximately 20 kilometers high. That's 2.5 times the height of Olympus Mons on Mars. If you dropped a rock off the edge, it would take 10 to 12 minutes to hit the bottom. But here's the thing. All of that, the entire catalog of Miranda's strangeness, comes from one flyby. 6 hours of close approach. One side of the moon photographed in usable detail. The northern hemisphere has never been imaged. We have no idea what's over there. In 2023, a study suggested Miranda might still be actively venting material into space, like Enceladus does, meaning this half-seen, geologically impossible little world might not be dormant. It might be alive. We looked at it once, briefly nearly 40 years ago, and moved on. It's still out there, still doing whatever it does, still half in shadow. Number 6. On December 8th, 1990, NASA's Galileo spacecraft swung past Earth for a gravity assist, a standard maneuver where a spacecraft uses a planet's gravity to slingshot itself faster, like a billiard ball off a cushion. The engineers at JPL calculated exactly how fast Galileo should be when it came out the other side. It was going faster. Not by much, 3.92 millimeters per second, but that's not an amount that should appear. Not in a system as precisely modeled as a spacecraft trajectory. The engineers checked for drag, atmospheric effects, mischaracterized thermal forces, every possible source of error. Nothing accounted for it. Then they checked the other flybys. Near, in January 1998, an anomaly of 13.46 millimeters per second, the largest ever recorded. Cassini in August 1999, roughly 2 millimeters per second. Rosetta in March 2005, 1.82 millimeters per second. All unexplained, all real. Here's the thing, someone eventually noticed a pattern. The anomaly seems to correlate with Earth's rotation. Spacecraft flying over the poles, pick it up. Spacecraft flying symmetrically around the equator like Messenger don't. And someone, and I find this part genuinely unsettling, wrote a formula. A mathematical expression that correctly predicts the size of the anomaly for each flyby based on the geometry of the approach. The formula works. Nobody knows why it works. It has no physical basis anyone can identify. It just fits. And then Juno flew past Earth in 2013 and showed no anomaly at all, which didn't solve the mystery. It just meant the formula also fails to predict when the anomaly won't occur. Something near Earth is nudging spacecraft in ways our best physics can't explain. We've measured it. We've partially described it. we cannot identify it. Number 5, Saturn has rings. Everyone knows this. What most people don't know is that the rings are probably not ancient. They're estimated to be somewhere between 100 and 200 million years old, based on the rate at which they accumulate dark dust from space, which means the rings formed around the time the first flowering plants appeared on Earth, not at the dawn of the solar system. Recently. This raises a question: where did all that ring material come from? The leading answer is that it came from moons. Earlier moons, a previous generation, that somehow fell apart, collided, spiraled into Saturn, shattered, and left their remains behind as rings. And from the outer edge of those rings, new moons are currently forming. Cassini actually watched this happen, small moonlets condensing out of ring material in real time. Here's the thing: the inner moons we can see right now, Mimas, Tethys, Dione, and Enceladus, show signs of being young. The orbital models suggest that if they were as old as the solar system, they'd be much farther out by now. Gravitational drift over 4.5 billion years adds up. These moons look like they're only about 100 million years old. And Enceladus, the moon with the plumes, the one with the subsurface ocean full of phosphorus and the building blocks of life, a 2024 study put its ocean at 5 to 15 million years old. 5 to 15 million. That's so recent that it barely registers on the geological scale. The moon we think might harbor life might be a newborn. Assembled from wreckage, its ocean younger than the Himalayas. Saturn is a planetary graveyard, and something in the graveyard is waking up. Number 4. Uranus orbits the Sun tipped on its side. Its axial tilt is 97.7 degrees, which means its poles take turns pointing almost directly at the Sun as it moves around its orbit. Every other planet in the solar system tilts less than 30 degrees. Uranus is nearly perpendicular. This is strange. This is so strange that it's been an open problem in planetary science for decades. The standard explanation, the one that appears in textbooks, is that something hit Uranus. A massive object several times Earth's mass struck it early in the solar system's history and knocked it sideways. A giant impact, clean, simple, done. But here's the thing: Uranus has moons, large ones, and they orbit at the same extreme angle, which means they share the tilt. If a sudden catastrophic impact knocked Uranus sideways after the moons had already formed, the moons should have stayed in their original orbital plane. They didn't. They tilted with it. The impact hypothesis can't cleanly explain this, so other theories exist: multiple smaller impacts instead of one big one, a long-lost massive moon that dragged Uranus over 90 degrees and then crashed back into it, a gravitational resonance with a hypothetical distant planet that slowly tipped it over without any collision at all. 4 incompatible theories, no consensus. The most basic fact about the planet, why it's oriented the way it is genuinely unsolved. And then in 2024, researchers reanalyzed the original Voyager 2 flyby data from 1986, the only time we've ever sent a spacecraft to Uranus, and they found something. The flyby happened to coincide with a rare, powerful solar wind event, a transient disruption that temporarily threw Uranus's magnetosphere into unusual chaos. The magnetosphere we observed during that flyby, the one that all our models of Uranus are partly built on, was not representative. It was Uranus on its worst day, having the worst magnetic weather it might have in years. We visited Uranus once. We caught it mid-catastrophe, and we didn't know for nearly 40 years. Number 3. The sun's surface, the photosphere, burns at about 10,000 degrees Fahrenheit, 5,500 degrees Celsius. Extremely hot, obviously it's the sun. Its outer atmosphere, the corona, reaches temperatures of 2 to 3 million degrees Fahrenheit, 1 to 2 million degrees Celsius. That is 200 times hotter. Further from the surface, further from the heat source, this is physically backwards. If you stand next to a bonfire, you're warmer, close to the flames, and cooler as you step away. Heat decreases with distance from its source. This is not a controversial law of physics. It is among the most basic things thermodynamics tells us, and the sun violates it visibly, constantly in every direction. We've known about this since 1939, when a physicist named Bankdead Len identified spectral lines in the corona that could only exist at temperatures of around 2 million degrees. The problem has been sitting there, unresolved, for 85 years. In 2018, NASA launched the Parker Solar Probe specifically to investigate. In December 2021, it became the first spacecraft to actually enter the solar corona. It flew through the sun's atmosphere. We touched the sun. Here's the thing. One of the mission's most significant results so far is eliminating a leading explanation, the S-shaped magnetic structures called switchbacks, which were thought to be a strong candidate for transporting energy from the surface upward into the corona, appear to form too far out to be the main driver. We went to the sun, flew through its atmosphere, and ruled something out. There are still candidates. Alphean waves, nanoflares, millions of tiny magnetic explosions happening constantly across the surface. A 2025 study from Queen Mary University found evidence for something called a helicity barrier that may be redirecting turbulent energy as heat. Progress is real. The answer is closer than it was. But the solar wind produced by this unexplained corona, this backwards physics-defying envelope of superheated plasma, extends all the way past Neptune. It engulfs every planet, every moon, every spacecraft we've ever launched. We live inside the outer atmosphere of a star we don't fully understand. It has been doing this impossible thing for the entirety of human existence, and we've only just started to figure out why. Number 2. About 1.2 billion kilometers from Earth, roughly the distance you'd travel if you drove around the equator 30,000 times, there is a moon called Enceladus. It's small, 500 kilometers across, about the size of England. And it has geysers. Not water geysers like Yellowstone. Geysers that shoot directly into space. Enceladus has a global subsurface ocean, confirmed. It has cracks at its south pole, called tiger stripes, through which that ocean vents plumes of water vapor and ice particles continuously into space. The plumes are so large they actually feed one of Saturn's rings. Cassini flew through them multiple times. Here's what Cassini found in those plumes. Water, obviously. Molecular hydrogen, which on Earth is produced by hydrothermal vents, the same kind that support entire ecosystems on the ocean floor. Complex organic molecules. Sodium, potassium, silica nanoparticles. And in June 2023, phosphorus at concentrations at least 100 times higher than Earth's oceans. And hydrogen cyanide, which sounds poisonous but is actually one of the key building blocks in the chemistry of life as we understand it. Phosphorus, hydrogen cyanide, hydrothermal vents, liquid water. The letters CHNOPS, carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, are the elemental shorthand for the building blocks of life. Enceladus is broadcasting all of them into open space. Here's the thing. You don't need to land. You don't need to drill. You don't need to dig. The ocean is already out there, already in space, already waiting. You just need to fly through it and collect it. Cassini did this, and Cassini ended in 2017. NASA deliberately crashed it into Saturn to avoid the risk of contaminating Enceladus with Earth microbes. The next dedicated mission to Enceladus is planned for no earlier than the 2040s. That's 2 decades away, minimum, possibly 3. We've known what's in those plumes since 2023. We've had the roadmap since 2017, and we are not going. There's a moon in our solar system that might contain life. It's literally throwing its ocean at us. And we are busy with other things. Number 1, count the planets in our solar system. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. 8. There used to be 9, and not in the Pluto sense. In 2011, a planetary scientist named David Nesvorny at the Southwest Research Institute ran thousands of computer simulations of the early solar system. He was trying to reproduce the current orbital arrangement, where the planets are, how the Kuiper belt is structured, why the terrestrial planets survived in the way they did, and he found something consistent across the simulations. The math worked better with 5 giant planets. Not 4. 5. An additional ice giant, similar in size to Uranus or Neptune in the outer solar system, which was then gravitationally encountered by Jupiter, accelerated past escape velocity, and ejected from the solar system entirely. Gone. A planet the size of Uranus, flung into interstellar space roughly 4 billion years ago. This isn't fringe. This is a peer-reviewed, widely discussed model published in the Astrophysical Journal Letters with follow-up work from the University of Toronto in 2015 that identified Jupiter, not Saturn, as the specific planet responsible for the ejection. Because if Saturn had done it, its moon Iapetus would have been destabilized. The fingerprints are specific, the evidence is indirect, but it's there. Here's the thing. The planet might not be gone. Some researchers believe the fifth giant wasn't fully ejected, that it survived the encounter and is still out there in an extreme, distant orbit, somewhere between 300 and 800 astronomical units from the Sun, maybe further. This is related to the Planet 9 hypothesis. And the Vera Rubin Observatory, which became operational in 2025, is conducting a survey of the outer solar system that should either find it or rule it out within the coming years. So there are two possibilities. Either our solar system executed one of its own members 4 billion years ago, and that planet is now drifting somewhere in interstellar space, untracked, undetected, possibly within a few light years of us, passing quietly through the dark between stars with no name, no orbit, no star to warm it. A rogue. Or it's still here, hiding, waiting in the cold at the edge of what we call home. Either way, the solar system we learned about in school is not the complete picture. The stable, elegant arrangement of 8 planets around a single star, it's a story told by the survivors. 8 worlds that made it through 4.5 billion years of chaos, collision, and gravitational violence. We don't know what we lost. We only know what stayed. And somewhere out there, past everything we can see, the evidence of that violence is still moving. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.